So this is notes 12, page 4, more on reducing fractions and restrictions. And then equivalent expressions as well. So reduce, give the restrictions when asked. So we are going to give the restrictions here. Do not even think about canceling terms. Those threes are terms. You cannot cancel terms. And earlier in the notes, I kind of went over that. Suppose you have 2 plus 3 over 7 plus 3. Okay? Well, that's 5/10, which is 1/2. Now, if you try to cancel the 3's, and I'm not really sure what you'd cancel them to, but let's say that we make them go away, that's 2/7. Well, 2/7 is not 1/2. If you cancel terms, you don't have an equivalent expression. You can cancel factors. So, if you're asked to reduce, you need factors to reduce. This is one of the reasons we learn to factor. Sometimes you need a factor, sometimes you need a term. When you're reducing, you need a factor. So I look at this numerator, m plus 3. I can't factor that, and that's 2 terms. Well, I can't reduce unless I have factors. Well, here's where you play your little sneaky game. Scoop it up in parentheses. Think of this as 1 times m plus 3. Voila, there's your factor in the numerator. Okay. And the denominator. Now, you have to factor it. It's a factoring problem. So all those steps of factoring you got to think about. Is there a GCF? No. How many terms? 3. Is it a pattern? No, that's not a perfect square. But it does look like it could come from FOIL with that quadratic term, linear term, and constant. It's got to be m and m. Everything's positive, and it has to be 3 and 1. Okay? So there. Now, here's the thing that you have to remember, though. The restrictions are always on the original form. So the restrictions are on this before you reduce. So before you reduce, look at that denominator and make sure no factor 0. Because think about it. 0 times any number is 0, right? So if this factor winds up being 0, it wipes out the whole denominator. So I'm looking at this. What would m have to be to make that 0? Well, opposites add to 0, so I better not let m be -3. And now look at that factor. Well, if that winds up being 0, 0 times anything will make the denominator 0. So I look at that. What would m have to be? Well, opposites add to 0, so if m was -1, that would be 0, so don't let m be -1. These are the restrictions. Okay. Now, for now, I'll probably just ask for the restrictions, just showing you the domain is really just the opposite point of view. I'm going to talk about this to kind of prepare you, because we'll be focusing more on domains eventually. The domain is everything you're letting m be. Well, m can be any real number except for the ones you threw out. And then you just list your restrictions. Let m be any real number except -3 and -1. So it's just restrictions, domains are just sort of 2 different points of view of the same idea, which is don't plug in numbers that make the denominator equal to 0. So now you're ready to reduce. The m plus 3's are identical factors, so they cancel to 1. So this is 1 over m plus 1. And this expression, this original expression, will give you the same value as this expression every time, as long as you don't plug in -3 and -1. So here's a plug for why we bother to reduce. Evaluate this expression if m is 1/5. Well, that looks nasty. But what I realize is that m plus 3 over m squared plus 4m over 3 is equivalent to 1 over m plus 1, as long as m is not negative 3 or negative 1. So with equivalent expressions, if I plug in a number for m here, if I plug in a number for m here, I'm going to get the same answer. I would much rather plug the 1/5 into the simplified form. So this is 1 over 1/5 plus 1. It's not that hard. It's a compound fraction, but not that hard. This is 1 and 1/5. And notice I'm going to add these first because parentheses are like, the fraction bar is like parentheses. And rather than saying 1 and 1/5, I'm going to convert that to a mixed number, which is 6/5. And then I'm going to remember where my big division bar is. So this is really the same as 1 divided by 6/5. And then remember, how do we divide fractions? We multiply by the reciprocal. So I didn't leave enough space, but that was just 5/6, which wasn't that bad. A whole lot easier than plugging in 1/5 into the original unreduced form. Now, I want to sort of drive home a point about the restrictions here. Because a common mistake is that people may only tell me that m can't be negative 1 as a restriction because the m plus 3 is gone from the simplified form. So, but even though the factor m plus 3 canceled out, we still can't let m be negative 3. The restrictions or the domain is for the original form of the expression. And remember, when I have this equal signs, I want to be able to say, hey, if you plug in m here or if you plug in m here, you're going to get the same answer. So let's try this. I didn't have this filled in yet. You need to fill this in. Okay, so here's the original form. Here's a simplified form. If you plug in negative 3 to the original form, you do get 0 over 0, which is undefined. If you plug in negative 3 to the reduced form, you get negative 1/2. And undefined is not the same as negative 1/2. So this equals up here is not true when you plug in negative 3. So when you have this equals, it needs to be true for all values of m that you're allowed to use. And so if it doesn't, equals doesn't hold for negative 3, you gotta throw it out. Okay, so let's try another one. All right. Reduce, we're gonna get the restrictions. 4 minus x squared over x squared plus 3x minus 10. Right here, check this out. Don't even think about canceling the x squareds. These are terms. You cannot cancel terms when dividing. That's like the cardinal sin of algebra students. I need factors to cancel or to reduce. So I'm going to factor the numerator. All right, no GCF. Definitely a pattern. Square root of 4 is 2, the square root of x is x. There's no middle term. That's a difference of 2 squares. This is 2 minus x times 2 plus x. Okay. Then I look at the denominator. No GCF. Looks like it comes from FOIL. It's definitely not a pattern. It's definitely x and x. Because that minus 10, it's 1 minus and 1 plus, and I'm pretty sure it's plus 5 minus 2. Okay. At this point in time, now give me the restrictions. So, remember for the restrictions, its denominators can't be 0. 0 in the numerator is fine, like 0 over 6. That's a problem. Like, I have $0 and I'm going to share it with 6 people. What does everybody get? 0, because I'm so generous. So it's just denominators can't be 0. So you look at the factors in the denominator. What would make the x plus 5 equal to 0? Well, the opposite there. So don't let x be negative 5. Now you look at the x minus 2. What would make that factor 0? 2. So x cannot be 2. Now, if, this is kind of some foreshadowing, if I asked you for the domain, just give me a different point of view. X can be any real number except negative 5 and negative 2. So you see how restrictions and domains are getting at the same thing, just different points of view. Restriction is what x cannot be. The domain is what x can be. So now we're ready to see if we have any identical or opposite factors to see if this reduces. I do not see any identical factors. But check this out. See how this is 2 minus x? See how that's x minus 2? Those are flipped around the minus sign. So if you take your shortcut, you know these will cancel. But be careful, don't write a negative 1 like that. It cancels to negative 1, but it cancels to a factor of negative 1. So the negative 1 would multiply into the answer. Generally, we like negatives in the numerator, so that's where we tend to put it. So it'd be negative 1, and I'm going to change that to x plus 2. Addition is commutative, over x plus 5. Okay, now, in the denominator, because this is a fraction bar, and there's no negative here, you can have the parentheses around the x plus 5 or not. You can't drop the parentheses in the numerator because it should be the opposite of the entire numerator. If you want, you can distribute the negative. However, it doesn't matter. Whether you distribute the negative 1 or not depends on your purpose, like the next step, and we don't have a next step, so you could leave the negative 1 as a factor outside the parentheses, or you could distribute it. It won't matter. A little aside over here for your doubting Thomases. You know, I said 2 minus x over x minus 2. I said, hey, that reduces to negative 1, a factor of negative 1. So just again, if you let x be 8, that would be 2 minus 8. 8 minus 2, that'd be negative 6 over 6. See how they're opposites? So that's why I call these opposite factors. And then if you want to show all the steps, you can factor negative 1 out of the numerator or the denominator, just don't do it to both. If you factor out the negative 1, negative 1 times negative 2 would give you positive 2. Negative 1 times a positive x would give you negative x. And then let's change negative 2 plus x to x minus 2. Now we have identical factors, but you see the negative 1 factor remains. So you can show all those steps if you want. But if you learn to recognize opposite factors, you know they cancel to a factor of negative 1. Okay, one last thing here, part C. Does this fraction reduce? Think about it. Okay. The answer is no. You got to be careful here. The factors of the numerator are 2 and a plus 5. The factors of the denominator are 1. You can always write that as 1. Scoop the 2a plus 5 in parentheses. The 2a plus 5 is a factor. There are no identical factors in the numerator and denominator to cancel. And if you get sloppy with parentheses or you're doing your math work at 3 a.m. in the morning, parentheses can float in your brain. You can overlook this and try to cancel something, so be careful. What restriction would have to be placed on A? this is a really important problem. Not as easy to see on the other one. So let me give you a strategy here if it's not popping out at you. Remember, the denominator can't be 0. So if you're not sure of the restriction, if you can't just look at it and say, oh, don't let A be this, write a little note to yourself. Hey, the denominator can't be 0. That means 2A plus 5 cannot be 0. Well, that's kind of like a little equation to solve. Subtract 5 from both sides. 2A should not be -5. A should not be -5/2. That's the restriction. That's the value that will make the denominator 0. The video's kind of long, but if you plug in -5/2, the 2's going to cancel. You're going to get -5. -5 plus 5 is 0. So you will need to find restrictions a lot. So remember this little trick if you didn't see it just right off the bat that, hey, A can't be -5/2.